grace and noble.
Hello, welcome again. And God said, "Let there be light." And there was light. And you are able to see me because of the light. Alright? And my face is glowing behind these lights. And therefore, let's talk about light. So, what is light? There is a definition for light. Light is the visible part of the spectrum of electromagnetic radiation. Remember this? I will be asking you while writing your test. What is light? Light is the visible part of the spectrum of electromagnetic radiation. So in this definition I said visible, spectrum, electromagnetic radiation. Now, going into history, why do we say it as visible? Because we are able to see light. In 1905, when the theory of quantum mechanics was propounded by famous Dr. Einstein, he said light travels in the form of tiny particles called photons. Yeah, tiny particles called photons. And later on, when he formed the special relativity theory, he also found and said to us that light also travels in the form of waves. So light is in the form of tiny particles as well as it travels in the form of waves. This is the most interesting part of light. Why do we say visible, spectrum, electromagnetic? Because we can see colors, right? So the spectrum has 7 colors. Yes, Vibgyor, Vibgyor, right? And you see the rainbow and you see 7 colors. So that's how when the white light splits and it forms 7 colors. So white light per se is not a white color. It's a combination of the 7 colors of lights. If you put 7 colors in a circle and revolve it fast, what happens? You'll see white light. This is how it forms. So, and then when I say spectrum, there is a range of the wavelengths. It starts from 390 nanometers until 700 nanometers. So it starts with violet and it ends with red. And what are the colors? Violet, indigo, blue, green, yellow, orange and red. We call it as Vibgyor. Clear? So each and every color has its wavelength. Shorter wavelengths and longer wavelengths. Shorter wavelength on the violet side, longer wavelengths on the red side. That is why when we see a traffic signal, what happens? Because of the longer wavelength of the red light, we are able to see red light from very far. They won't put violet light there because it's a shorter wavelength, not visible from the far, right? So this is what the visible part of the spectrum is all about. And the properties, it's electro and it is magnetic. So it's the properties of light, which we don't want to delve into too much, but this is the basics of light. So the behavior of light is called the field of optics. When we go and learn more about light, then we are going to involve ourselves with the field of optics. And when it is coming with images and angles and lines, then it is called geometric optics. Okay, we'll not go too much about measuring the angles, etc. But basically, we will be talking about the overall optics of it. Then what happens is that when light travels and hits the object, or when it travels and penetrates through the object. These are something which we need to know. And when light travels, hits the object, not able to penetrate it and comes back, that object is called opaque. Through an opaque object, light cannot travel because it bounces back. And mostly it is like a mirror. When light falls on a mirror, it's an opaque object and it returns. Or light falls on a wall, it's an opaque object, it's not able to penetrate, it returns. And if light falls through a glass, it's transparent. And glass has a refractive index, so it has to bend the light. Likewise, we see light travels through water, light travels through diamond, light travels through transparent objects. So when light travels through a transparent object, it passes through, it also bends. But sometimes what happens is the object is neither transparent nor opaque, so it's called translucent. Translucent means only a partial light travels through. Now, having said this, what is a reflection and difference between reflection and refraction? Reflection, we will also learn about the laws of refraction. Reflection is nothing but when light hits an object, it comes back, it's a reflection. If it is able to reflect, some objects are not able to reflect. If you are going to put the light on a wooden plank, it's not going to reflect. If it is on a mirror, it reflects. If it's a steel plate, it reflects. If you put light through water, it refracts, refract, and that's called refraction in optics, which we will learn more about it. And there are laws of reflection and refraction. We'll learn more about it. Now we'll be talking about reflection and refraction. So when we talk about reflection, what did I say? That light, when it hits the plane, it bounces off. And it is important that the material has to reflect light. If it doesn't reflect light, then it absorbs the light. So it's an opaque object, of course, but it doesn't reflect light. In most cases, as you see, the walls, the wooden planks, and etc., light doesn't get reflected. It does reflect to some amount, not entirely. But in a plain mirror, for example, you will see most of the light gets reflected. So what is the law of reflection? An incident ray, the ray which comes in is called the incident ray. The ray which bounces off is called the reflected ray. This is you have to remember. Incident ray, reflected ray. Angle of incidence is equal to angle of reflection. That's it. Don't remember much. Don't need to know much as of now. This is all laws of reflection is all about. Angle of incidence is equal to angle of reflection. The coming ray is known as the incident ray. The reflected ray, the ray which goes out, is called the reflected ray. Now, talking about refraction. What is refraction? When a ray passes, when light travels from one medium through the other medium and comes out, then it gets refracted. How does it happen? For example, when light comes from vacuum, comes from air and goes through water and comes out, for example, so you will see the bending of light happens. As a result of this bend, the result of the bending is because of the refractive index of the material. This is what you need to know. And what is the refractive index is all about? Every material, transparent material, has a refractive index. Okay, if it is air, if it is vacuum, it's 1. If it's air, close to 1. If it is water, 1.33. If it is glass, 1.5. If it is diamond, 2.42 is the refractive index. Imagine how much of light must be bending inside a diamond because of the high refractive index. When we talk about a lens, most of the lenses are made out of glasses and plastic these days, CR39, which we'll talk about more. So the basic index there, we start with 1.5. 1.5, then 1.55, 1.6, 1.67, 1.74, In the glass, we have the refractive index until 1.9. Yeah. Beyond that, I don't know. If you come across, do let me know. As of now, we have the highest refractive index of a material is 1.9. Now we are going to talk about something which you will practice on a day-to-day basis all through your life when you are a part of the field of optics. That's going to be about lenses. What are lenses? Converging lens, diverging lens. Simple. Alright. Converging lens is a plus lens. When light passes through a converging lens, it comes to a point. It's called the focal point. When light gets spread through, when it passes through a lens, it's called a diverging lens. So this is what we are going to talk about. First of all, before we talk about the lenses, there is something called prism. Alright, prism is a triangular in shape. If you keep it like this, alright, the apex, the top part of it is called the apex, as you can see in the picture. And if you keep it like this part is called the base. Alright, so if the bottom is the base, the top is the apex. What happens when we are making a lens? Either we make it base to base or we make it apex to apex. If we make it as a base to base, this is the base and this is the base. So that lens is like a convex lens. This is a lens, right? This is a nice lens. Alright. If you normally you will not see it when you have a lens, but inside the lens you will have it something very thick at the center. So it means that it's a base to base lens. It's a convex lens. And what's a convex lens? How to see it? When a patient comes to you and shows you the spectacles, you look through the spectacles and you see it like this. It magnifies. A convex lens is a plus lens. It magnifies the image. Very simple. The moment you look at it, do the movement like this, it will be magnifying the image. And also there is something called the movement of the lens. If you move the lens sidewise, there is called the with movement and the against movement. If it's a convex lens, then you will have an against movement. Alright, so these are the properties of the lens. If you have a convex lens, the image will magnify. If the light passes through it, it will come to a focal point, it focuses. Alright, and then the image will be moving against if you look through it. This is important in a convex lens. But if it's a concave lens like this, concave lens shape, don't look at a lens and see, the thin lens that you will have, it's inside this thin lens you will have a convex or a cave. All you need to do is catch at the center of it. If it is thin, then it is like to be concave lens. If it is thick, then it's like to be convex lens. Convex lens is a plus lens. Convex is a plus lens. Concave is a minus lens. So in a concave lens, it's apex to apex. It means it's the opposite. So naturally it will be thin at the center, thick at the periphery. And what does the concave lens do? It spreads light. It diverges light. So, and also if you look it through the center and shake it, the image will be minimized. It will not be magnified. It will be minimized. And then what about the movement? The movement will be with movement. If you shake it like this, the movement will be with movement, as you can see from the images. So now we have a convex lens. Then we have a concave lens. Right? Clear? Now going forward, we will also see astigmatic lenses. Before we see about astigmatic lenses, we will also see how does a presbyopic lens looks like. Presbyopic is always at the reading level. When people are not able to read, they will always have plus lenses. If somebody is saying, I don't have a problem with the distance, everything is perfect, I'm only not able to look at a book and read it properly, look into a computer and not able to read it properly, they have reading problem, and therefore it's going to be a plus power. We'll discuss more when we talk about myopia, hyperopia and presbyopia, but a reading lens is always a plus lens. It comes at the bottom. So when we talk about progressive lenses, we'll talk in detail about reading lenses, but right now we are only talking about a convex lens and a concave lens. Then we will also talk about astigmatic lenses. What are astigmatic lenses? Astigmatic lenses is nothing but, when you have the shape of the eye in most cases is like a football, spherical in shape, round. All right. So when the patient has a problem with vision, so there is only one issue. Either it could be myopia, the image falling right in front of the retina, or behind the retina, right? So, but this is in the spherical issue. If the shape of the eye of a patient is like a rugby ball, like an egg, for example, then you have two surfaces, which one side is flat, the other side is curved. I mean, it's a spherical shape. So in this case, you will have astigmatism. Again, we will discuss more about this with pictures, but here we are talking about a cylindrical lens. When we talk about a cylindrical lens, what happens is, if you look into the lens, spectacles like this, okay, in front, okay. So if you are going to do like this, it can magnify, it can minimize, right? But if you want to look into the lens and see if it is turning, then it is most likely to be astigmatic. It's most likely to be, because unless if there are no aberrations in the lens, otherwise it's definitely astigmatic, because the lens is fixed at an axis. Therefore, if the patient has only minus or plus, if you are going to change it like this, in terms of move it like this in terms of its shape, then you are not going to see the movement, because the object will be very fixed. If it's an astigmatic patient, then if he has a cylindrical lens, then the object is going to move, and thus you will be able to understand this patient has cylindrical lens. Okay, that's it for now. See you soon with vision correction. We'll talk more about myopia, hyperopia, on all those wonderful things, so that you can understand it and make it something amazing for yourself. All right, see you soon.